Thanks for that, Kaiser. Well, hello everyone. My name is Ewan Garden, and I'm a program manager working on Spark as part of the big data group here at Microsoft. And specifically today, we're going to talk about Spark as part of Azure Synapse Analytics. We got four big areas we're going to try and cover. We're going to do some high-level stuff. We're going to do some low-level nerdy stuff, and hopefully everyone is able to get something out of the content. So while I know Savine has already covered this, well, the first thing we're going to do is create a Spark pool. I'm going to talk about the different characteristics of a Spark pool and also talk about what the impact of making changes to those is, how it works, and what you need to think about when making some of those choices. So that's how we'll start off. Then we'll go ahead and we'll go and take a look at some code, and we'll explain how to scale and optimize your Spark pool and how to understand what's going on within the Spark environment, some tooling to help you go look at more details and more information. And we'll look at both open source tooling and we'll also look at tooling that we've built at Microsoft that's unique to the Synapse world. We'll take a look at some open source technologies that we have created at Microsoft that help accelerate, and also some open source technologies which we're including as part of the project. And finally, we'll take a look at a new way of building analytical apps from a data perspective. Traditionally, and this is going back 25 plus years, when building an analytical system, we take a copy of the data out of the operational system, we dump it into a staging area, we start doing data prep on it, and then when it's clean, we push it back into the staging area, which in the old days was relational database and today is the lake. And then we start consuming and producing from there. And so there's a more modern, different way of doing that we have within Synapse Analytics called Azure Synapse Link. And we're going to take a look at how that actually works and how it can change the game a little bit. All right, enough of the talking and the slide deck. Let's go ahead here and we will get rid of PowerPoint and we're going to switch to our user experience here and no more PowerPoint from now on. All right, so I'm going to go ahead and create a Spark pool right now. I have a couple of choices. I could have created it inside of Synapse Studio, but we're going to go spend a bunch of time in Synapse Studio. And so let's go ahead and do it inside of the Azure portal. So I'm going to select New Spark Pool here. And we're going to call this one Live Demo. And the reality is that's the only thing we need to do to create a Spark pool. It'll go ahead and it'll take the defaults, it'll set it up. The defaults are pretty good, but that's it. Now, in our case, we're going to spend a lot of time going through the details here. And so you're going to want to maybe think about changing some settings once you understand the implications of changing those settings. But it's very simple and clean to be able to do this. So let's go through the different elements of the user experience. So starting out here, we only support one family of SKUs today inside of Spark pools, and that's the memory optimized SKU. Now, some people have used general purpose SKUs, some people have used storage optimized SKUs, they've used CPU optimized SKUs. We've done a lot of analysis of a lot of systems, a lot of Spark in HD Insight and various other places, and we really feel like these memory optimized SKUs offer the best price performance. And it means it's easier for us to do optimizations because we're optimizing for one hardware configuration. And one of the big things about these SKUs is you get 8 gig of RAM per vCore, which is a lot. And Spark is a memory-bound system in that it tries to do as much in memory as it possibly can before swapping to disk. And so having 8 gig per core really, really helps the performance and the scale from that perspective. All right, so we're going to use memory-optimized nodes. And we have a choice of node sizes. And we've quite a lot of choices here, ranging from small to extra, extra large. And each one of them has a different core count, but each one of them still has 8 gig per core. And so all we're really saying is, how are we dense packing the cores in this particular case? Now, one of the things to think about when you're thinking about what node size to choose is the node is actually a scaling factor within your Spark instance. And so we're going to talk about autoscale in a second, but when we scale the cluster, we can't scale using this type of scaling. We can't scale by individual executors. There's another way of doing that, but here we scale by actual nodes. And so if I have a small number of very large nodes, it means that, for example, if I look at extra, extra large, if I need 65 vCores,